Hello everyone and welcome to today's video where we'll go through 8 questions from the radio navigation topic. This is a mix of all the latest questions that have been seen across all EASA authorities. So we'll try to go relatively quickly through all of these. I'll try to give you some tips for all these questions for the actual EASA ATPL exams, as well as some extra explanations. So without any further ado, let's just jump into the question number 1. The MLS frequencies are in the... So this is a great question that you can actually see in almost all the radio navigation exam, because the syllabus requires at least 1 or 2, I believe, questions from the microwave landing system on each of the exams. Just so you know, microwave landing system, so the MLS, is something that has been created as a superior version of a precision approach system to the ILS. However, because of the rise of the GNSS approaches, so we have the RNP and RNAV approaches that superseded the ILS and essentially fixed everything that MLS was supposed to fix much faster and much cheaper. The MLS has never really caught up in Europe and anywhere in the world. At the moment, I don't believe there are any working MLS stations in Europe, or maybe there is one in the US or 1 or 2 TOTs in Europe, but you'll essentially almost never fly this. The aircraft that I fly in an airline does not even have an MLS in its multi-mode receiver. So this is purely theoretical. Going back to the question, the MLS is better than the ATPL because although it has a slightly smaller range, up to 20 nautical mile, it allows for curved approaches, and this was what was better than the ILS, as the ILS does not do so. Now we can do the same with the RNP authorization required approaches. The MLS works in the super high frequency band, so it's a higher frequency than the ILS, and it has a separation that allows for 200 available channels. You don't really need to know much more than this. Remember that it works on the azimuth principle, and that should allow you to answer almost all the MLS questions in the actual exams. For question number 2, you're approaching an aerodrome on an RNP approach to LNAV-VNAV minima using Baro-VNAV. The approach has a minimum temperature of -8 and the outside temperature is 10 degrees Celsius. During the final approach, ATC tells you to go around immediately due to loss of terrain separation. What could have happened? So this is a fantastic question that demonstrates the importance of knowing how the RNP system works. So the required navigation performance is different than the standard RNAV because it requires alerting and monitoring. It means that the system is monitoring the integrity of your signals, and it will actually alert you if any of the signals from the satellites becomes faulty, and it can also exclude this using the RAIM, which is the onboard augmentation system, allowing you to monitor the signals. And of course, because it's an RNP approach, this means that any error of the satellite's GNSS signals or the RAIM will give you a warning in the aircraft. So if the warning has not occurred, it means that you made a human mistake, human error, by inputting a wrong QNH, and essentially you busted the altitudes. This is why you making a mistake inputting barometric data will most likely be the cause of this incident regarding the RNP approach to VNAV minima. In case of RNAV, however, there is no requirement for monitoring alerting, so this could be slightly different. Now going to question number 3, the RNP AR approach is used. The authorization required RNP approach, as I already mentioned before, is a great approach that allows for curved approaches, and because it is so sophisticated and more difficult to fly, it also requires the airline to be approved and certified by different authorities for this, hence the authorization required. These are only meant to be used in the approach and already final approach phases of flight, as they require very, very little errors from the system. Hence, they are very, very accurate. And as mentioned, they are mainly used in curved approaches, such as, for example, in Nice, France. Number 4, what is required to fly an RNP approach with LPV minima? So, of course, the LPV minima is a type of a GNSS approach. The difference between LNAV, VNAV, and LPV is that, first of all, the LNAV, VNAV uses barometric inputs in the VNAV navigation, whereas the LPV is fully GNSS. However, the main difference is that LPV guides you with an angular deflection for the signals, so the same as ILS, whereas the LNAV VNAV gives you a lateral deflection meaning a cross track from left to right. This also means that LPV becomes more sensitive the closer you fly to the threshold of the runway, whereas for the LNAV BNAV, this is simply a cross track of left to right and is the same throughout the entire approach. LPV minima allow you to fly down to Cat 1 minima, so the same as a precision approach. The exams want you to know that LPV is a precision approach. However, by theory, this is a discussion topic. I would not say that LPV is strictly a precision approach. However, it can be flown to precision approach minima of 200 feet. Of course, it requires SBUS, so it requires a very accurate positioning, as well as final approach segment data block, which is an additional amount of data that your aircraft needs to receive navigation-wise in order for you to have this LPV minima guidance that you can fly. And now going to question number 5. So referring to this annex, what is the amber text RNP1 and the ANP indicating? Of course, this is taken from a Boeing navigation display, the ND. And if it becomes amber, this means that something is not going as it should. The RNP on the left is the required navigation performance, and ANP is the actual navigation performance. It means that for you to fly on this route, you should navigate with precision with an error of maximum 1 mile left or 1 mile right. The ANP means that your actual navigation performance ensures the error is 1.35 left or 1.35 right. This means that the error is too much and you are not allowed to fly along this airway. This is taken from a Boeing. In an Airbus, this will be shown by an estimated position rather than the actual navigated position annunciation. However, this means that the navigation performance is out of limits and your aircraft essentially is navigating with this error. It does not mean that it is 1.35 miles cross track, because it might as well could have been 0.5 miles cross track. However, the aircraft is not able to guarantee that it is less or more. Now for question number 6. The Airborne weather radar is displayed on a colored screen showing the different contours associated with thunderstorms. What procedure should be adopted to avoid a thunderstorm using the Airborne weather radar? Remember for these questions that Airborne weather radars operate in the SHF band, and that you should never ever fly into the red cells, which are the heaviest precipitation, or the magenta cells, magenta colors, which show you the turbulent areas. In most cases, the magenta colors will be in Doppler equipped aircraft, because the Doppler is what we use, the Doppler effect. So the shift of particles is what we use to detect turbulence. By law, we are required to circumnavigate the thunderstorms within a radius of at least 10 nautical miles below flight level 200 and 20 nautical miles above flight level 200. In an unlikely event where you have to overfly a thunderstorm, you should always aim to do so with a separation of at least 5,000 feet. And so, of course, lastly, remember for all the questions that the thunderstorm should always be avoided on the upwind side, meaning that the thunderstorm is pushed away from you rather than towards you when you are overflying. So going back to these answers here, of course, 5 nautical miles is too little. Flying towards the area where contours are the steepest and avoids any areas that are yellow. You do not have to, whether I think you should, and it is a good idea to avoid those. And flying on the upwind side, so the thunderstorm is pushed away from you, and avoiding red or magenta colored areas is an absolute must, as these can cause safety issues and can be very uncomfortable and dangerous to the safety and health of your passengers. Going to question number 7 here. An aircraft is on an ILS approach to runway 23 using an approach plate with the diagram in the annex. The pilot with the markers selected on the intercom sees an amber cockpit indicator light on the marker panel. What is the approximate DME indication? So this is a question that you will also most likely see on most of your RNAV exams. And because you need to know the ILS markers, these are not used that often anymore. These were very popular, especially if there were no DME stations co-located with the ILS. Today, most of these will be co-located with an ILS, and you do not really need to pay that much attention to them. However, it is good to know. Different markers, so the outer, middle, and inner markers will tell you how close you are to the threshold of the runway. These all have different colors and different frequencies. You should remember that essentially the carrier frequency of 75 megahertz is the one that carries it, and then of course each signal will be slightly different So the frequencies will rise from the lowest at the outer marker to the highest at the inner marker. The way to remember the colors of these markers and how they shine in a cockpit, I recommend using a mnemonic of BMW, the outer being B, blue, the middle being M, amber, and the W, white, being the inner one, BMW. So of course, in this case, if we have an amber one shining inside, this means that this is a middle marker, BMW, blue, amber, amber, and white, so 1 nautical mile away from the station. And now for the last question, number 8 that we have here for today. The NDBs, or non-direction beacons, are used for navigation as A. And the question, of course, here wants you to answer the locator beacon to start the final approach segment. The locator is a type of NDB that has a very short range and is only used in the final approach approach segments, or sometimes in the arrivals as well. However, the locators are not used in the for navigation en route or for the airways, as some beacons can be used to do these things. Of course, the other questions do not make much sense. The DME beacons only give you range. This is the direction measuring equipment. The VORs, or the VHF omnidirectional range, gives you a radial from the station. And the markers, as we already explained, are used to fly along the ILS final approach for you to know where you are on this last final descent. And this will be everything for today. This was a relatively quick one, a bit different, more information. However, I hope this was helpful. If you have any questions, as always, feel free to ask. I highly recommend that you download the Airhead app or register an account online, so you'll be able to see all these questions and see the explanations as well. Until then, I wish you all the best. I hope you do fantastic on your exams and have a great rest of your day. Thank you for watching, and bye-bye.